So in this section, section 1.6, we're going to be solving rational equations. Now, a rational equation is just an equation that has a fraction in it. So lots of people will tell you fractions are your friends, but I disagree. So the first thing I want to do is get rid of fractions. First, out of the block, get rid of them. The way you do that is you multiply each side by the least common denominator. Least common denominator. I call that the LCD from now on. And then we solve the equation. Once you get rid of the fractions, you're going to have like an algebra 1 equation, maybe as high as an algebra 2. But what you must always check is that the answer that you get when you plug it back in does not give you a denominator that is 0. If that's the case, it's a solution that does not actually work. So this is a fairly short section. We have about 5 examples. So let's start out with this one. So I need to find the least common denominator, the LCD. The way that I do that is first thing I check for is an x squared in the denominator. Notice this one does not have an x squared. So I do not have to try and break it into parts to see what's in there. Okay, I don't have to factor it. So I'm just going to look at the very first denominator. That denominator is x minus 5. So I'm going to put that on up there with my least common denominator. Then the next one is, if you look underneath, there is nothing there. So I'm going to just assume it's a 1. So I would go ahead and put like 1 up here, but 1 times anything is just the same thing. So I'm not really going to worry about putting the 1 up there. Then the next thing is the last denominator, and it's x minus 5. I already have it up there. So my least common denominator is now x minus 5. So now I'm going to multiply everything by x minus 5, each side, right? So whatever you do to one side, multiply by x minus 5, you've got to do to the other side. And then it's legal to do that, right? So once I multiply by the x minus 5, I'm going to have to distribute it. Right? So really, I like to think of it as multiply each piece by x minus 5. Okay? So that's what I'm going to do from now on, is I'm going to multiply each piece by x minus 5. Now we're going to go back through and cancel if we can. Now remember to cancel. Whatever is on the bottom must be exactly the same as whatever is on the top, and then they'll cancel. So in this case, I can cancel the x minus 5s on the very first one. So what I have left is just, all I have left is my x. So then I'll write that down, x. And then I go to the next one, and I have a plus. Right, I got a plus there. So let me write the plus down, x plus. Now, can I cancel anything? I've got a 1 on the bottom, and I can't really cancel that with what I have on top. So what I have left is a 5 times x minus 5. So I'll write that down, 5 times x minus 5. And then I have an equal mark. That's what we have that left over. So equals, and then cancel one more time. Those x minus 5s cancel. So the only thing that I have left is that 5. So I have a algebra 1 equation, right? I don't have any squares. I'm going to distribute that 5, because I can't have any parentheses and an answer, right? I'm trying to get it to be x equals a number, so that doesn't have parentheses. Let's see, I need to get x's on one side, so I'm going to combine my x and 5x and get 6x. And so I've got my x's on one side. Now I'm going to take my numbers, move them to the other side by adding 25. So I'll have 6x equals 30. Then I get my x by itself by dividing. So I get x equals 5. Now remember, this x equals 5 is the answer to this equation after I got rid of my denominators, okay? So 5 is the answer to that one, but it may not work in the original. So I need to take this 5 and I need to plug it in my denominators. Well, the very first denominator I plug it into, notice I get 5 minus 5 equals 0. Uh-oh, we can't have a 0 in the denominator. So that solution doesn't work. We only had one solution. It doesn't work. So this is a no solution problem. There isn't a solution. Students get frustrated when they do all this work and they're like, I didn't even get an answer. But you actually did. You got an answer that said nothing, no number that you can think of is ever going to work. So that's pretty good. Anyway, my lab doesn't say no solution. They say the solution is the empty set. Okay, so there'll be like a dot there that'll say the solution is the empty set. And then they'll have some other dots that say solution is, and it'll give you a blank. Okay, so you're just going to fill in the solution is the empty set for that one. All right, let's go back to the next one. Now notice the denominator of example number 2 does have a squared in it. Okay, so that means we need to factor it to figure out what the pieces are. So notice it is a difference of squares. 4x minus 1 is a difference of squares. So I'm going to factor that into 2x plus 1 and 2x minus 1. If you ever have issues factoring, usually one of the other denominators, and sometimes both of the denominators, if you multiply them together, a lot of times you will get that factored form. So anyway, once I factor it, I usually cross out the non-factored form just so I realize that I don't have to deal with that anymore. All right, let's go to our least common denominator. So I always go to the very first fraction and write down whatever is there. So that's 2x plus 1, 2x minus 1. Then I go to my next one, and there's 2x plus 1 there. Notice that is already up in the least common denominator, so I don't have to write it down. When I go to my second, or actually the third fraction, I also have 2x plus 1, and it is there. The only time I would need 2x plus 1 times 2x plus 1 in my least common denominator is if both of them were underneath one denominator. In other words, if that first one had been 2x plus 1, 2x plus 1, then I would have two of them up there. All right, we're going to do what we said before. We're going to multiply each piece by 2x plus 1 and 2x minus 1. I'll also show you a shortcut. But a lot of students that don't write it down mess up. So I'm going to go ahead and write it down, but I'll also show you the shortcut. Okay, so now we're going to go ahead and cancel. So my 2x plus 1's cancel and my 2x minus 1's cancel, so that all I have left is my 8. And then I have an equal mark. So I'm going to write down 8 and equals. Now notice that everything canceled on the denominator. Okay, that should always happen. When you multiply by the least common denominator, if something is left in the bottom, you messed up. Okay, your least common denominator is wrong. Let's go back and cancel again. The 2x plus 1's cancel, but the 2x minus 1's do not cancel. So all I have left is a 3 times 2x minus 1. Now here's where you could use a shortcut if you wanted. You could have said, okay, I know the 3 is going to be there because that's not going to cancel. That's in my numerator. And then you could look and say, okay, I've got 2x minus 1. What is left in that least common denominator? What's left is the 2x minus 1. So 2x plus 1 was there. What we're missing is 2x minus 1, which is what I'm going to be multiplying by. So you could do that instead of writing it all down. I'm going to cancel again 2x plus 1. So I have what's left is I've got a 3, right? I've got my 3. And then I have my 2x minus 1. So once again, I would write down, the shortcut is to write down the plus 3. Because I know I'm going to have that. It's in the numerator. Then I look at the denominator and the least common denominator, and I say, okay, what am I missing? And what I was missing is the 2x minus 1. So I'd be writing my 2x minus 1. Once again, I now have an Algebra 1 problem. I've got to get rid of my parentheses, so I'm going to go ahead and distribute. So I've got 8 is 6x minus 3, and another positive 6x minus 3. And then I simplify everything on the right-hand side. I'm going to get my x's together, so that gives me 12x. I'm going to get my regular numbers together. That gives me minus 6. And then I'm going to solve. Move the numbers to one side. I already have the letters on one side. And then I divide by 12. So my answer is going to be 14/12, but I can reduce that by dividing everything by 2, right? So that's going to be 7/6 is my answer. Okay, again, before I circle it, I'm going to make sure that if I plug it into my denominators, here or here, or here, that I do not get a 0. Now, here's the thing. I don't care what you get. I just want to make sure it's not 0. So when you're plugging it in, you don't have to worry that it's this weird fraction, 7/6. Well, 7/6 is close to 1, right? A little more than 1. So if I took, and put a little more than 1, 2 times a little more than 1 is going to be a little more than 2 plus 1. That's going to give me, a little more than 3. I know it's not 0. And then I would need to try this one with the 2x minus 1. So 2, a little more than 2 minus 1 is not going to give me 0. So I know that actually is a solution. So x is equal to 7/6. All right. Got 2 more before we get sort of a weird one. Notice that both of these have a quadratic on the bottom, have x squared. So I'm going to have to split that. I'm going to factor that first. So x squared minus 3x, if I take out an x, that gives me x times x minus 3. So now, least common denominator. I go to the very first one, and I have x minus 3. Write it down. Then I go to the next fraction, and I have an x. Now notice that I do have an x in my least common denominator, but it is super glued, right? It is super glued to this -3, okay? So I can't like separate the x and cancel and say, oh yeah, I've got an x up there. So I have to also put a separate x. So x minus 3 times x. And then look at the last one. I have an x up there. So I do have an x up in the top. And I have an x minus 3 up in the top. So I don't need any more. I can't cross that out. And again, you can, if you want to, you can write that x times x minus 3 for every one of them. Or you can do it in your head. I'm going to go back and cancel out my x minus 3. So the way you do it in your head, if you remember, is you're always going to write down the x minus 5, okay, or the whatever's in the numerator, because I can't get rid of that. That does not cancel. And then I'm going to compare my denominator to my least common denominator, and notice that the thing I'm missing is my x, and that's what I have left. So I'll write down my x. Then I'm going to have my plus. I'm going to write down my 1. And again, if you're canceling, you can cancel out the x. So I'm going to need a 1. And notice that plus 1, by the way. And then if I compared my least common denominator to my denominator there, my x, the thing I'm missing is the x minus 3. And so that's what I'll write down, x minus 3. I really didn't have to write that 1 down. Anyway, now I get equals a minus 7. So equals a minus 7. And notice that everything cancels, or the shortcut is I'm not missing anything in the least common denominator. So once again, I have an equation that has no fractions. I'm going to distribute my x to my x minus 5. So x squared minus 5x. Notice I now have a squared in my new equation, okay? plus x minus 3 is negative 7. So when you have a squared, you know you've got a quadratic. So that means I'm going to solve it either by completing the square, which I would not suggest, or quadratic formula or factoring. Okay, all of those have to be set equal to 0. So to solve it. So I'm going to simplify and say minus 5x plus x is minus 4x. And then I'm going to move my 7 over by adding. So x squared minus 4x, what's that? Plus 4? And let's see if I can actually factor it. Factors of 4 are 1 and 4 and 2 and 2, and they need to add, right? They need to add to give me my negative 4. So, or to give me 4. And notice that 2 and the 2 will add to give me 4. So it will factor. So x and a 2. And I need it to add to give me a negative 4. So both of those will be negative. So I've got 2. Now you could take each one of those and set them equal to 0 if you wanted. Okay. But I just look at it and say, you know what? I can just look at it and know that this would need to be a 2 to make the x minus 2 equal 0. I'm going to do the same thing there. So I have two answers, but they are the same thing. So x equals 2. So once again, remember that the 2 is a solution to the equation we got after I got rid of my fraction. So I'm going to take that 2, I'm going to plug it back in the bottom. It does not give me a 0 for the first one, doesn't give me a 0 for the second one, and doesn't give me a 0 for the third one. So x equals 2 is my solution. All right, let's go to the next one. Again, I have an x squared, so I'm going to go ahead and factor that. So that's x squared minus 25. Once again, it's a difference of squares. So I will have x plus 5 or x and x minus 5. Or you can write it x minus 5, x plus 5. Doesn't matter as long as one's plus and one's minus. Least common denominator. I go to the first one, x plus 5. I'm going to write it down. X plus 5. Then I go to the second one, x minus 5. That is not up there, so I've got to write it down again. I've got to write it down as well. And then I go to the last one, x plus 5 is already up there. X minus 5 is already up there, so I've got my least common denominator. Then I can go ahead and multiply each piece by that, or I can use my shortcut. Remember, your shortcut is write down your x, okay, whatever is on the top, and then look at your least common denominator. I already have an x plus 5, right? So what I'm missing is my x minus 5. So I could just go ahead and write that down, x minus 5. Again, if you want to multiply each piece by the least common denominator and cancel, you can. All right, again, I'm going to write down my plus 5. All right, I always write down what's on top. What am I missing? I've got an x minus 5, so I've got this one. So I'm missing my x plus 5. Then I write down my equal mark. Write down the 50. Once again, compare. What am I missing? I am at the least common denominator. I'm not missing anything, so I'm not going to write by everything would have canceled. So once again, I have just a regular equation with no fractions. So I'm going to distribute my x, get x squared minus 5x, and then distribute the 5 and get plus 5x plus 25 equals 50. Let's simplify. My x's, isn't that interesting? My x's in the middle just cancel out. So I'm going to just have x squared plus 25 equals 50. Okay, so from here, there's two ways of simplifying. All right, I'll show you one way. Remember, we talked about if you have just a plain old x squared and you don't have any of these other x's, you could use a square root method. So to use a square root method, I would move the 25 to the other side. So it would look, my steps would look like this. Subtract 25 on both sides. So I get x squared is 25, and then I take my square root. So I get x is 5, but remember, I get two answers because I started with x squared. So that means it's going to be a positive or a negative, plus minus 5. So you could use the square root method to do that, or you could have said, okay, I'm going to factor this guy. Well, when you factor, remember, you need to subtract 50 and get it all, get it set equal to 0, right? And then this is a difference of squares, x plus 5 and x minus 5. And so the first answer would be a negative 5, and the second answer would be a positive 5. Do you see that these guys are the same? All right. Now, again, this is the solution to this guy right here, okay? So it's a solution to what it is once we get rid of my fractions. So let's go and make sure that when I plug in my minus 5, I don't have an issue. So if I plug my minus 5 into the first equation, do you see that I get a 0? So, that is not a solution. Doesn't work because I get a 0 in the denominator. Now let's plug my 5 in. Now notice that it works in the first one, but in the second one, doesn't work on the second one. I get 5 minus 5 gives me 0. So that one doesn't work. So once again, we have a no solution problem, or the solution is the empty set if you're in my lab. Okay. Now, so far, it's been an all or nothing. That does not always happen. You might have one where, the where the negative 5 doesn't work and the positive 5 does work. Okay. But in this case, both of them did work. All right. Let's do one more problem, and this is something that you're going to use a lot in higher math courses. It's where you take a little bit harder problem and write it in terms of a not so hard problem. So notice we now have an x to the 4th. Okay, so there's several ways that you could work this, but I want to show you a technique that's used a lot in calculus and other problems. Okay, so it's also called the chain rule in calculus. But anyway, I am going to see if this thing was not x to the 4th, if it was x squared. We would be like, oh, we just factor it. So we're going to make it look like an x squared. And the way we do that is we're going to turn this x to the 4th into something squared. So I'm going to let u, and I don't know why mathematicians use u, but they often do. They're going to let u equal x squared. Okay, we're going to let u equal x squared. So I could rewrite this initial equation as 3, if it'll let me write, sorry, 3 times x squared squared. You see that? That would give me x to the 4th. So 3x squared squared plus x squared minus 2. So now, do you notice that my x squared, wherever there's an x squared, I'm going to stick in my u. So I'm going to have 3u squared plus u minus 2 equals 0. And now I can factor that. There's bunches of different ways to factor it, okay? But it's the one where I have that 3 in the front. So I'm going to use slide and divide, okay? You do not have to use slide and divide. It's just one of my favorites. So I'm going to move that 3 over with the 2. So I'm going to wind up with u squared plus u minus 3 times negative 2 is negative 6, right? So minus 6 equals 0. Now this factors. I'll have u and a u. And what do we get? 2 times 3. 2 times 3 gives me 6, and it subtracts to give me 1. So I need a positive 1. So I'll have a positive 3 and a negative 2. That's the factored form. Now that I'm not trying to solve for u, right? I'm trying to solve for x. And I'm not, if I, this would be an answer of, the first one would give you an answer of positive 2. But if you put positive 2 in here, you're not going to get a 0, okay? Because that is the solution to this guy. All right, so it's called slide and divide. And that's where most people mess up, is the and divide. So whatever you slid, we slid the 3, that's what we divide by, right? The number you slide is the number you divide. So that's going to be u minus 2/3 and u plus 1, okay? And now I'm going to, there's 2 ways you can do this. If you really want to see it factored, you could move the 3 back up and get 3u minus 2 and u plus 1. Okay, that is the factored form, but I usually don't do that, okay? I usually don't do that. When I'm solving for it, I can just look at the second one, see, and know that that's going to be -1 because it's always going to be the opposite, right? Because if I subtract 1 on both sides to solve it, I get -1. The same thing here, though. This u is just going to be a positive 2/3. Okay, just move it to the other side. Now we're not done, right? Because I don't want to know what u is. I want to know what my x is. So I'm gonna substitute back in. I'm gonna say x squared is equal to 2/3, and x squared is equal to -1. So I just plugged my u back in, or my x squared back in for my u. And now I've got this thing where you have x squared equals a number, so I'm going to take the square root of both sides. Square root of both sides. So in this case, I get x squared is, excuse me, not x squared. Should just be a regular old x, right? So I get x equals the square root of 2/3. And again, you have somebody a long time ago that said you can't have a square root on the bottom. And you notice that is a square root on the bottom. Square root of 2 over square root of 3. Can't do that. So I have to rationalize my denominator. So just multiply by the square root of 3, and see that turns the bottom to 3. Whatever you do the bottoms, you got to do the top. So my x is going to be plus or minus the square root of 6, because I'm going to multiply the 2 and the 3 together. They're both square roots. So they're both single, so they can party together, right? So 2 times 3 is 6. And on the bottom, I have a 3. So that's one of my answers. So that's for that guy. Now let's do this guy. I'm going to take the square root of both sides. So I now get x equals plus or minus the square root of -1. Well, -1 doesn't have a square root. It's just I. So I have 4 answers. I need to make sure, normally we go back up and plug it back into my equation, but I do not have to do that because it's not a fraction. So those are the actual solutions. So I have, my solutions are plus or minus square root of 6 over 3. And you could write that out as square root of 6 over 3, negative square root of 6 over 3, plus or minus I. So notice I have 4 solutions, and I started off with x to the 4th. So that's normal. All right, so we've now finished this section. So you are ready to work your homework project.